Hi, I'm Charlotte,
I'm Rohit.
and this is our final project for ECE. And special thanks to Noah Legg and Sajid Muir.
The goats. Alright, so the goal of this project was to create a two-way communication circuit. So we have a microphone and an aux input on one circuit, and we have to block the DC signal from our microphone, and then add the two signals together from the aux and microphone, transmit that signal through a laser, and that signal will then hit a photodiode on the other side, which will then amplify it and output to a speaker.
Alright, so we need to power the supply of both circuits, the receiver and the transmitter. And we're not powering them with one whole battery for everything. We kept it separate so that there's no feedback from the transmitter to the receiver, because we had problems with that and with the ground, and they all connected. So we kept them as two separate entities. We had one 9-volt battery for one and one for the other. And how we did that is we have a 9-volt battery, and those are connected to two receivers that are equal to two resistors that are equal to the same, so that you can have a 4.5 and a negative 4.5 coming out. And it goes through an op amp, which is works as a buffer and gives a virtual ground.
So for a transmitter circuit, the first thing we did is we took the mic, we filtered out the DC using a capacitor, and then we put it through an op amp to amplify that signal. So this is a non-inverting microphone amplifier. So our V input is going through the positive terminal of this op amp, and we have our RF and R1, so that there's a gain of 1.5. So this is a 10 kilo ohm resistor, this is 20, and 10 divided by 20 is 0.5. And with a non-inverting amplifier, you have a gain of 1 plus RF divided by R1. After that, we have an aux cord, microphone, and also a voltage going into a summing amp. So our aux cord has a high-pass filter, and then that's going to a summing amp. Our microphone just has a resistor that's going to a summing amp. And the reason why we have a voltage source that goes to the summing amp is because we want to create a DC offset eventually. So generally, if we just took our speaker and connected it to the output without having any DC offset, it would look like that. So laser would be intermittent and it wouldn't transfer that signal properly. So we have to offset that voltage so everything's positive. This is really bad drawing. 1 second, guys. This way, the sound doesn't cut off, and the DC offset makes it so that the laser will stay on continuously, even when the oscillating wave goes down. Back to this part. So everything goes into a summing amp. This is an inverting summing amp because our V-in is going into the negative terminal of the op amp, and we've chosen our RF value to be 0.5. So if you do the math, RF divided by R1, you'll find out that our voltage has a gain of 1, our microphone has a gain of 0.03, and our aux has a gain of 0.05. Notice that these gain values are very, very low, and that's because we want to preserve that signal when we spit it out into the laser. So after that's happening, we put a resistor to protect the laser, and there you have it. That's our transmitter circuit.
Alright, so for the receiver circuit, we take the signal that comes from the laser from the transmitter, and it hits the photodiode. And initially, there was not enough voltage if we didn't have the amplification part, which is here. So we added this amplification through the op amp with a resistor of 5 kilo ohms, and the amplification is about V equals IR, and it depends on the voltage, the current that comes out from here, and the resistor that comes from here. So a higher resistor value would give a higher voltage, but we didn't want too high to saturate, so we kept it at 5K for the amplification. And then the second part of it is after we amplify that signal, we go through a filter right here, and then we put it into a non-inverting amplifier to get a gain of 19.5, like roughly about that from these two resistors over here, and that will like amplify that sound to go into the speaker. And first it's filtered and it goes through a potentiometer so that there's volume control, and there's also volume control through the transmitter for the microphone and for the amplifier, but this is like the third component so that the receiver can also change their volume, and then it goes out to the speaker, which is also connected to a negative 4.5 to power it.
What do you want to try?
No, good. Okay, and then volume down, volume up. Was that?
Hello, hello, hello. Can you hear me? Oh yeah, you can.
Alright, so this is the output voltage from the speaker. So this is it without any sound. So there's like, it's very small. And then I'm gonna add a 500 kilohertz. And there it is.
Oh, for a distance? Yeah.
So this is the output voltage from the laser. So that was when it was on, and then when it's off, it's just nothing. Alright, so this is the output voltage from the photodiode, and we amplified it through the amplifier because there wasn't enough voltage. So here it is without. So there's nothing, and then here it is with.
Like a lot.
So this is the frequency response of the laser. So I'm doing like a 1 kilohertz sound. Let me flash it on.